So think learning goals. What are the learning goals if you were to teach, say, fifth and sixth graders about division of fractions? On the one hand, the learning goal could be, I just want them to get the right answer. Or the learning goal could include understanding, sense making, developing ways of thinking. Obviously, I'm going to encourage and argue for the second. And if you have the second, the first will be wrapped up in it. You'll get right answers if you understand, make sense, etc. So I want to take you through a quick introduction to this idea, rethinking the division of fractions. I say rethinking because it has often been the case that division of fractions has been taught this way.
Dividing fractions. And it turns out that if you know how to multiply fractions, you actually know how to divide fractions as well. That's because dividing fractions is exactly the same as multiplying by the reciprocal. And if you don't know what that means, multiplying by the reciprocal is the same thing as flipping the second fraction and then multiplying.
It's
So let's
just
just
what you
get
do.
started right away with this example. Here we have 3/5 divided by 2 over 3. So once again, dividing fractions is exactly the same as multiplying by the reciprocal. The
I wonder
reciprocal of
why.
2 over 3 is 3 over 2. Once again, I just flipped the numerator and the denominator. And now these fractions can be multiplied quite easily. First, I'm going to multiply the numerators. 3 times 3 gives us a 9. And then in the denominator, we have 5 times 2, which is just 10. So let's just go over a couple
Let's
more
just do it
examples.
again.
I'm going to write this example in a little different format. Let's say we have 1/2 all divided by negative 1/3. So this is exactly the same as 1/2 divided by negative 1/3. And once again, dividing is exactly the same as multiplying by the reciprocal. So I'm going to take the 1/2.
But why? Why would
and I'm
that
going
be?
to multiply it by the reciprocal of negative 1 over 3, which is just negative 3 over 1. Now I'm going to multiply these two fractions together. I'm going to multiply the two numerators. 1 times negative 3.
Promoting whole number multiplication instead of fractional
And 2 times 1
thinking.
is just 2.
And then
So
there's
here are
just
some more
examples,
videos.
more examples.
Some more examples.
Yeah, exactly. Now, the cool thing about this in our YouTube age is you can look at comments. And so here's the comments of people who watch this video. OMG, thank you so much. Oh my God, you are so helpful. If this guy was a teacher and you were in his class, you would become so smart. Do you always flip the second fraction? Now, this is a thoughtful, King AJ, this person is really thoughtful because this person's thinking, I wonder why. Why is it that division is exactly the same as multiplication by the reciprocal? Do you always flip the second fraction then multiply? I wonder why. And then Amy, typical student, you're going to read about this in an upcoming R&R, but the student would say, don't you take the LCM, the lowest common multiple or the least common denominator is another way to say it. Don't you take the LCM? Students have learned, because they haven't learned to make sense of fractions, they just know that somehow with fractions, common denominators are a thing. Don't you have to do that since we have fractions? And then I love this one. I forgot how to divide, and so this helps so much. I forgot how to divide. I wonder why you forgot. You forgot because it never made any sense, and you clumped that algorithm amongst many others that didn't make sense, and so you couldn't remember which algorithm to use. And then look at this one. I just realized I watched the same video a few months ago. Dividing fractions is something that can be easily forgotten, isn't it? Yeah, things are easily forgotten when they're not made sense of. When the brain doesn't make sense of things, it doesn't hold on to it. It lets it go out. And so we've got to do some work. So my introduction to this, I want you to be thinking about it. These are things you've been thinking about all course long, but I want you to be thinking about this, the absence of meaning. Did you see in that video, which is a pretty common approach to teaching division of fractions, by the way, but the meaning of division is not even present at all. What does it mean to divide? And if division means that, then what doing should occur because of the meaning? That's this left out. There's no real world context. I'm going to challenge you to think about this soon. But can you imagine a real world, real world context where you and your outside of academics, outside of your 5th, 6th, 7th grade life, you were like in a situation where you said, oh my goodness, I have to divide these fractions. And then this is one of just many procedures lacking conceptual grounding. As you're going to read about in an upcoming R&R, sometimes you cross multiply. Sometimes you multiply straight across. Sometimes you get common denominators. Sometimes you keep the first fraction, change division to multiply, flip the second fraction. There are so many algorithms and procedures that many students lack any conceptual grounding, and so they don't know what to do and when to do it. And so again, I ask, what is the learning goal? If the learning is just to get the right answer, that would be one of your two options. One of the options, get students to get the right answer to a fraction division situation. And I would argue, if that's the option, we have technology. If only getting the right answer matters, then just hand them some technological device, which we've had for years now. There's even calculators that will let you input fractions and will output fraction answers. If it's just about getting the right answer, technology can do it. Or is the learning goal to develop mathematical ways of thinking that lead to procedural fluency so that students know that they should divide, they understand what division means, and they may have multiple strategies or algorithms, depending on the context, by which they can get the right answer. Of course, I argue for the second one, which brings us to what you've been reading about. All this semester, I know you haven't finished it yet, but all this summer you've been reading through the Beyond Answers textbook. And in Beyond Answers, our Arizona State standards, which come from the Common Core standards, have these 8 standards: making sense of problems, persevering, reasoning abstractly and quantitatively, constructing viable arguments. Now, I want to focus on that one as we go into this division of fractions. On the one hand, we can just say, this is how you do it. Remember how to do it, and I'll keep reminding you how to do it when you forget, because if it doesn't make sense, you'll probably forget, so I'll have to keep reminding you. But I'll just keep reminding you how to do it. Or we can help students to think and reason so that they can construct a viable argument about fraction division and critique the reasoning of others. They can model, what model in this sense means apply it to something real, take a real life problem and create a mathematical model for it. They can use appropriate tools. As you're going to see, tools in this case might be more cognitive tools, like sometimes common denominators are a great tool for fraction division. Sometimes the invert and multiply is a great tool for fraction division. We'll look at the different tools as part of our fluency. Of course, we want precision in all of our thinking, answers, computations, and all. We'll look for structure. This can be a big one too, because I'm going to take you through a learning flow, a learning progression, where you're going to see the algorithm emerge from our thinking. And by looking for structure, we're going to do that in this repeated reasoning sense, so that at the end of the thinking, the division algorithm will make sense, is the goal. All right, a student I had in the past in this particular class said in some written reflection that I had asked, maybe it was an R&R, I don't remember exactly the context, but Karina says this: there is more than one way to look at dividing fractions. Students should be given alternative methods to divide fractions so that they feel comfortable performing such computations. It should make sense, though. What is the reason of learning something if it doesn't make sense? I can still remember the sayings I would memorize for my math course to pass a test, but I don't even know how they apply or how to use them in math anymore. Students need to make meaningful connections to what they're being taught in class in order to remember it for future problems. I love this quote because, yeah, this is what I'm trying to instill in my students through this course, is to have them think about mathematics in hopefully different ways and more meaningful ways. But this little quote just jumps out at me. What is the reason of learning something if it doesn't make sense? if all we do is teach students, hey, when you divide, you keep the first fraction, you change divide to multiply, and you flip the second fraction, if that's all we're teaching them to do and it doesn't make any sense, why are we teaching it? That's a good question, Karina. All right, so with that introduction, we're now going to flow into a progression of thinking, a progression of reasoning abstractly and quantitatively, looking for structure, looking for and expressing regularity and repeated reasoning so that we can construct a viable argument as we model with mathematics and think about division of fractions. Are you ready? Go to the next slide and let's see how this plays out.